In this video, I want to discuss the standard form for the equation of a circle. Remember, the circle is all points within a fixed distance from a given point called the center. So the important properties of a circle are knowing the center and the radius. If you know those things, you can sketch a circle. The standard form for the equation of a circle reveals those properties. It has those properties built into it. It looks like this: x minus h squared plus y minus k squared equals r squared. And these values all mean something. The value h and k are the center of the circle, and this value r is the radius of the circle. So if we see an equation written in standard form, we can pull out this important information, the center and the radius, very quickly. Let's practice with this equation first by writing the equation of the circle with center -2, 4, and radius 3. So let me fill that in to the standard form. Here's the center, here's the radius. It looks like this: x minus h is -2. So x minus -2 squared plus y minus 4 squared equals the radius squared. The radius is 3. Let's simplify this as much as possible. X minus -2, if I subtract a negative, that's like adding a positive. So x plus 2 squared plus y minus 4 squared equals 9. Here we've simplified it and we have the standard form. Notice that this x plus 2 squared results in an x value for the center of -2. So if this sign is positive here, the center has a negative value. If this sign is negative, the center has a positive value for that y value. That's just the way the formula works out with those minus signs built in. Second, what are the radius and center of the circle given by x plus 2 squared plus y squared equals 14? Well, we've already talked about this part. If I see a positive sign here, I could rewrite that as x minus -2 if I want to strictly make it fit the formula. And then I can recognize the x value of the center is at -2. But what about the y value of the center? This just says y squared. It doesn't look like anything is added or subtracted, but you could think of this as y minus 0 squared, just to make it fit the standard form. So that means the y value of the center is at 0. Finally, we need the radius. The radius, well, we know that r squared equals 14. That's this number here. So the radius should be the square root of this. I take a square root of both sides, and I get r equals the square root of 14. I'm just going to leave this in its radical form. That represents some decimal number, the square root of 14. Finally, let's look at a challenge example that brings together some of the formulas we saw from an earlier video together with the equation of a circle. I want to find the equation of a circle that has the points -3, 1, that's right here, and 3, -7, that are opposite endpoints of a diameter of the circle. Well, we need to define the word diameter. A diameter passes through the center of a circle and it touches both edges of the circle. So it's twice the length of the radius, because a radius extends from the center to one edge of the circle. So I drew this line segment connecting the two. We know that in order to find the equation of a circle, I need to find these two things. I need the center and I need the radius. So let's see how we can identify these two properties of this circle. All that I know now is this is a diameter, so the circle looks something like this. I can't draw a very good circle, but that's a rough sketch of it. First, let's find the center of the circle. That should be the midpoint of this line segment, because the center will be directly in between these two outer points. Let's find the midpoint between -3, 1 and 3, -7. We know that the midpoint formula says average the x values and average the y values. Okay, so what do I get out of this? Simplified, I get negative 3 plus 3 over 2. That's 0 over 2. So that's 0. And I get 1 plus negative 7. That's negative 6. Divided by 2 is negative 3. So the center of this circle is 0, negative 3. Let's go ahead and put that in, and it's even shown fairly accurately on my picture. So there's the center of our circle. Now we need the radius of the circle. What's the radius? Well, the radius is this distance, right? Or you could say it's this distance. You can choose either one. It's the distance from the center to a point on the circle. How do we find this distance? Well, let's use the distance formula. So let's say that I am finding the radius with these points. The midpoint is 0, negative 3, and the outer point here is 3, negative 7. So we know from the distance formula that d, or I'm going to call it r in this case, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So negative 7 minus negative 3 squared. Let's simplify this result. 3 minus 0 squared is 3 squared, plus negative 7 minus negative 3 is negative 7 plus 3. This is going to give me negative 4 squared. This equals the square root of 9 plus 16, which is the square root of 25, which is a perfect square. The square root of 25 equals 5. So this circle has a center at 0, negative 3, and it has a radius of 5. If you would have used this point and this point to calculate the radius, you should get the exact same answer. The radius should be 5. All of these points on the circle are the same distance away from the center. So what's the equation of our circle? Let's write it up here. Now that we have it, we say it's x minus h squared. So x minus h is 0, x minus 0 squared, plus y minus k squared, y minus negative 3 squared, equals r squared. R is 5, and so I'll put in 5 squared. Let's simplify this as our very last result. So I get x squared plus y plus 3 squared equals 25. Here's the equation of the circle that is described by this graph.